we're going to start with that. We know that 5 plus 3 is 8. If we take 5 and add 3 to it, we get 8. Just like when we had fractions, when I had 2/3 and I decided I was going to multiply the bottom by, say, 4, whatever I do on the bottom of a fraction, I must do the same thing on the top of the fraction. Whatever you do on the bottom, you have to do on the top. Whatever you do on the top, you have to do on the bottom. The same principle applies with equations. When you have something equal to something else, whatever you do on this side, you have to do the exact same thing on this side. So let's say if I take the 8 and I add 2, this is now 10, but this is not. So since I added 2 over here, I have to add 2 over there. Whatever I do on one side of an equation, I must do the exact same thing on the other side of the equation. 5 plus 3 plus 2 is 10. I have not changed the equality. Yes, the values are different on each side of the equation, but I have not changed the equality. Both sides are still equal to each other. If I take that same 5 plus 3 equals 8, and I decide I'm going to take the 8 and I'm going to subtract 4. Well, 8 minus 4 is 4. But 5 plus 3 is not 4. So I have not kept the equality. So if I subtract 4 on this side, I have to subtract 4 on that side. Then 5 plus 3 is 8, and 8 minus 4 is 4. So even though I started off with 8 on one side and 8 on the other side, and I have a different value, the equality has not changed. Both sides are still balanced. So like he said, think of this as a seesaw. Whatever you do on one side, you have to balance it out on the other side. If I take that same 5 plus 3 equals 8, and I decide I'm going to divide it by 4. If I divide by 4 on this side, this gives me 8 divided by 4 is 2. If I take and do that, I have to do the same thing on the other side. And now with fundamental order of operations, we never really talked about this, but a fraction bar is a symbol of inclusion. It's sort of like a parentheses. It tells you that you must do whatever you have on the top and whatever you have to do on the bottom, and do those independently until you get them simplified down to one number, and then you can evaluate or simplify the fraction. So 5 plus 3 is 8 over 4, and 8 over 4 is 2. We started with 8 on one side and 8 on the other. We ended with 2 on one side and 2 on the other. The equality stayed the same. The equation stayed balanced. We did not lose anything from one side or the other to cause it to tip one way or the other. We kept it in balance. Okay? So, if we move to taking one of those numbers out and replacing it with a variable, m plus 4 equals 6. We want to know what m is. Well, with equations, there are two main rules. The first rule is we want the variable by itself on one side of the equation. Okay, we want the variable to be by itself, either on the left or the right, it doesn't matter, but we want to get that variable by itself. That's rule number one. Rule number two is that you do the inverse operation to get numbers away from the variable. So as that guy was talking about, if things are being added, then you subtract. If things are being subtracted, then you add. If things are being multiplied, then you divide. If things are being divided, then you multiply. You do the inverse of whatever the operation is. So back up here to this problem, I'm adding 4 to the m. I want m down here at the end to be by itself. So this 4 has to go away, because that's the only way to get m by itself, is to get the 4 away from there. Okay. Now, when you were in school, you may have learned to write, and you'll see it sometimes in other videos and so forth, where they do the subtraction underneath. They say, okay, I'm adding 4, so I'm going to subtract 4 to that side and subtract 4 from that side. I don't like that, because that then starts to look like you are doing division, and it becomes very confusing. So I don't teach it that way. I teach it the way that guy was doing. I say, all right, I'm adding 4, so I need to subtract 4 so that that becomes 0. That's the whole idea, because if that goes away, m is by itself. If I do that on this side, I must do the exact same thing on the other side. And now, like he was talking about, you may look at that and say, well, I don't need to write all that down. Yes, you do. Yes, you do. Yes, you do. Because the equations are going to start to get much more difficult. And if you don't learn the process and write the steps the way they need to be written now, you're going to be so lost when we get further down. Okay, so yes, you need to write the steps down. So on this side, the whole reason of subtracting 4 was so that when we add this stuff together, so see how our adding and subtracting integers are coming back? Positive 4 and negative 4, those add up to 0. That's gone. So I'm left with m. And then on this side, we evaluate that. 6 minus 4. Evaluate means find the answer. 6 minus 4 is 2. Now, he was doing this thing with this bracket over here on the side. I don't know what that was all about. That's not necessary. We don't write that. I think he was just trying to point out that you got m by itself. But you do need to remember to check your answer. If I put 2 back in here, I would have 2 plus 4 equals 6, and 2 plus 4 is 6, and 6 equals 6. So this is a correct answer. All right. If I am subtracting, and I'm going to move the variable to the other side this time. If I have 10 equals x minus 3. Okay. The whole idea is to get x, the variable, by itself on one side or the other of the equation. So I look at what is being done to the x. I'm subtracting 3. So in order to get this x by itself and this negative 3 to disappear, the only way to do that is to add 3. Because negative 3 plus 3, there's our adding and subtracting integers again. Everything we've learned in the past, we still need to use it in the future. And so this adds up to 0. If we add the 3 on the right, we have to add the 3 on the left. These 3's divide or add out. We're left with x. On this side, 10 plus 3 is 13. We can check our answer because 10 equals, if we put 13 in for x, 13 minus 3 is 10. Both sides are equal. That's a correct answer. If we are multiplying, if I have 5k equals 25. Remember, he was talking about the fact that if I write a number next to a variable, that means multiplication. There are lots of ways we can write multiplication. You'll see it written 5 times k, 5 with a dot, 5 times k. Sometimes you'll see an asterisk. Sometimes we write it in parentheses. Sometimes we write only one of the numbers in parentheses. And sometimes we just write the two things next to each other. Every one of these mean the exact same thing. We are multiplying 5 and k. When we're working with equations, this is the way you're typically going to see it written. So in this problem, we are multiplying 5 times k. To get k by itself so that it's all alone on one side, we have to undo that 5 times. We have to undo the multiplication. The only way to do that is to divide by 5. If I divide this side by 5, I must do the exact same operation on the other side. The two sides have to stay in balance, and they stay in balance by doing the same operation on both sides. Now, this means that our 5's divide out. See how we're coming back to simplifying fractions? Everything we've done in the past, we will use in the future. So the 5's divide out. That means we're left with k. On this side, we can evaluate. 25 divided by 5 is 5. I can check my answer by going back to the original equation. 5k equals 25. Put the 5 in for k. 5 times 5 is 25. 5 times 5 is 25. Both sides of the equal sign are the same. That is the answer to the equation. If we have one where we're dividing, x divided by 4 equals, let's see, let's do 5. X divided by 4 equals 5. In this case, we are dividing by 4. The x is being divided by 4. So to undo that, we need to multiply by 4. We undo division by multiplying. If I do that operation on this side, I need to immediately write that I'm doing that operation on the other side. Here we are back at fractions. 4 can be written as 4 over 1. This really becomes 4x over 4. 4 times x is 4x. 1 times 4 is 4. Equals 5 times 4 is 20. Simplify fractions. The 4's divide out. We're left with x equals 20. You could have done that in this step and said these 4's divide out, and I'm left with 1 times x over 1 times 1, which is just x. You'll learn to save some time and some writing by simplifying as you go. But we're still writing our steps down, showing what we are doing to get to our answer. If I go back to that original equation and I put 20 in for x, 20 over 4 equals 5. 20 divided by 4 is 5. 5 equals 5. That's the solution to the equation. If I gave you 6 plus 4, 6 plus 4, y'all tell me in the chat what that's equal to. Everybody? Okay. Just want to make sure y'all are there. Okay. So this is equal to 10. So I can do anything to both sides of that equation as long as I do it to both sides. Just like when we had our fractions and we had 3/4 and we said we can multiply the bottom number by any number like 5. If we do that on the bottom, we must do that on the top. Anything you do on the bottom of the fraction, you do it on the top. Anything you do to the top of a fraction, you do it on the bottom. 6 plus 4 equals 10. If I decide that I'm going to take the 10 and add 3 to it, right now, I've just thrown the whole thing out of balance because 10 plus 3 is 13. 6 plus 4 is not 13. 6 plus 4 is 10. But if I add 3 to this side, I must add 3 to this side. 6 plus 4 plus 3 is 13. If I take that 6 plus 4 equals 10, and I take the 10 and I multiply it by 4, I get 40. I've thrown the whole thing out of balance unless I take this side and multiply it by 4. 6 plus 4 is 10 inside the parentheses first. 10 times 4 gives us 40. So just as with fractions, the equal sign has to make sure that we keep everything in balance. Okay, if we don't keep things in balance, then the two sides aren't equal to each other. So if I start with x plus 3 equals 7, and he talked about the fact that you should be able to look at that and tell what the answer is. We all look at that and say, what number do we add to 3 to get 7? It's 4. So why do we have to write all this gobbledygook down? Well, there's a reason, and I'm going to show you in a few minutes what that reason is. There's a process, and we've got to learn the process. So on this side of the equation, we're trying to get x by itself because there are two main rules with equations. Rule number 1, get the variable alone on one side of the equation. That is rule number 1. The variable has to be isolated by itself on one side. Rule number 2. Whatever operation you do on one side of the equal sign, you must do the same on the other side. You have to follow those two rules. Rule number one, get the variable by itself. Rule number two, whatever you do on one side, you must do the same thing on the other side. So our goal is to get x by itself. So we look at the operation that's being done. In this case, we are adding 3. In order to get rid of that, we're going to subtract 3. Notice that I'm writing my equal signs down because you have to do that. And I keep them lined up. I want you to keep your equal signs lined up as much as possible. When you do something on one side, you need to immediately write down the same operation on the other side. If you don't, if you do on one side and you keep playing around with that one side and whittling it down, you're going to forget to do what you needed to do on the other side of the equation. Believe me, I've been teaching this for 20 years, high school math for 20 years, and I've seen it every single time. All right. So, positive 3 minus 3. Oh, wait a minute. Have we seen that before? Yes. Are positives and negatives, adding positive and negative numbers together. The whole reason for subtracting the 3 was so that it would add out with this 3. This is going to give us 0. They add out, which leaves us with x. That was the whole idea. Then on this side, 7 minus 3 is 4. We can check that by taking 4 and plugging it back in. 4 plus 3 is 7. Now, this thing he was doing by writing that on the other side, I'm not sure what that is. I've actually never seen that before. We're not doing that, so I don't want you writing that. All right. Nine equals x minus 2. Well, again, we should be able to look and say, well, I know that 11 minus 2 is 9. But we've got to learn the process. The process is important, and writing the steps and doing it in a neat and clean and logical order is going.
Hello.
Okay, I'm back. All right. I don't know what happened there, but my computer freaked out a little bit. All right, so we're learning the process here. And so if I have 9 equals x minus 2, then the operation that's going on here with the x is that I'm subtracting 2. So I'm going to write down my equal sign. I'm keeping them lined up. On this side, I have x minus 2. To undo the subtracting 2, we add 2 to that side. Whatever I do on one side, I must immediately do the same operation on the other side. All right. Then on the right side, -2 plus 2 adds up to 0. That's why I've been having y'all do these. Yeah, I think mine's being a little bit weird too, Mr. Washington. But that's why I've had you do these warm-ups that have the positive and negatives in them, because I know that we've got to keep knowing how to do that, because that stuff's not going to go away. We're still going to have to know how to do it. And so -2 plus 2, we know that adds up to 0. That's the whole idea, getting that stuff to add out. We're left with x. This side we can evaluate. 9 minus 2 is 7. Oh, I'm sorry. Whoop, I'm supposed to add 2. See, if you're not careful, you make mistakes. So my operation was to add 2. I needed to add 2 on this side. We get 11. Plug that back in. 11 minus 2 is 9. That works. All right, now I want to show you something, because you may have remembered doing these kind of problems in school, and your teacher may have done it this way. I'm going to say m plus 6 equals 9. And you may have learned to write what you're going to undo underneath. And so some teachers teach that since I'm adding 6, I subtract 6. If I do that on this side, I do that on this side. And then they draw a line. The 6's here add out, and I'm left with m, and 9 minus 6 is 3. Again, some of you may have remembered learning it that way. I don't like that. I don't teach that, because what's going to happen is, as we get further into this is going to start looking like division, and you're going to think that you're dividing and not adding and subtracting. So I don't like to teach it that way. I want to teach it where addition and subtraction is done on the same line, because we're now going to move to problems like this. 3x equals 15. We are multiplying both sides. We are taking the x and multiplying it by 3. So we have to undo, we have to break away the 3 that's being multiplied. The only way to do that is to divide by 3. Whatever you do on one side of the equation, you must turn around and do the exact same thing on the other side. And now we have 3x over 3. Wonder if we've ever seen that anywhere. All of our work with fractions and simplifying fractions, all of that's coming back. This is going to take every single thing we've learned how to do and push it all together. And that's what happens in math. You learn something, and then you use it the next day. You learn something, you use it the next day. You learn something, you use it the next day. So here, these 3's divide out, and I'm left with x. And then we do the calculation. 15 divided by 3 is 5. Notice that I'm keeping my equal signs lined up. I'm writing my steps down. I'm keeping it nice and neat and clean. That's going to be important. And I'll show you why in a few minutes. All right, let's say that we have 14 equals r divided by 2. 14 equals r divided by 2. In this case, we are taking r and dividing it by a 2. So to undo that division, we need to multiply by 2. Whatever you do on one side, you immediately write down that you have done it to the other side. 2 times 14 is 28. And on this side, that 2 is really 2 over 1. We've talked about that before. You can take any integer and write it as that number over 1. It's still that same number. And so when we multiply fractions, we multiply the tops, we multiply the bottoms, and then simplify. Or if you can simplify before you multiply, you do that. On the top, we get r. On the bottom, we get 1. R over 1 is r. I have my equal sign written down. It's lined up. My problem is nice, neat, and clean. I can go back and look at this 10 years from now and be able to look and see exactly what I did. That's what I'm going to want from you. Step by step by step. Because let me show you why. Because the next thing we're going to do on Thursday is you're going to have equations that look like this. 3x minus 4 equals 9. Ooh. Now we've added a little bit more to it. Then, when we come back from 4th of July holiday, you're going to see equations that look like this. 4x minus 9 equals 7x plus 2. Oh my word, we put an x on both sides. What in the heck are we going to do? Then we're going to move to equations that look like this. 3 times x plus 4 equals 9. Oh my word, now we've thrown a parentheses in there. Then we're going to move to problems that look like this. 3 times 2x minus 1 plus 2 times 4x plus 3 equals 11. And then they're going to turn into 4 times x minus 1 plus 2x minus 3x plus 4 equals 2 times x minus 3 plus 4 times x minus 1. So if you don't follow the steps, if you don't learn to write every single step down neat and clean, you will never be able to do that. That's right, Ashley. But I will promise you, if you trust me and you let me teach you step by step, and we will move from one type of equation to the next, when we get to these, you're going to say, oh, geez, Mr. Boslock, those are not that hard. Because really, they're not. Once you have the process built in and you have learned to write things down and not skip steps and not try to do things without writing them down, it'll be a breeze. And I guarantee you, you're going to see things like this on the GED. You're going to see them. They're there. So we've got to take baby steps, and we've got to learn the process and how to do it step by step. Okay, so we're going to do some problems together.
If you liked this video, please click on the thumbs up. If you want to see more videos like this, please click on the subscribe button. And if you want to be notified when new videos are posted, please click the bell.